This is HRW913P060. We've got two satellites on a collision course in the same orbit. They're both the same mass around Earth. They want to find the total mechanical energy EA plus EB of the two satellites plus Earth system. Now I'm going to ignore the potential energy between A and B and see if we get the right answer, and if not, we'll add it in. Okay, so we want EA plus EB. Wow, both of them have potential energy with Earth and kinetic energy all on their own. So the potential energy of A will be UA. Then I need the kinetic energy of A. Then I'm going to have to add in the potential energy of B and the kinetic energy of B. Okie dokie. Well, in general, potential energy is G M1 M2 over R. I'm going to call each satellite M1 and Earth is M2. And in general, kinetic energy for an object in a circular orbit is G M over 2R, where M is the mass of the big thing and M is the mass of the small thing. Haha. Okay. By the way, both of those came from a lecture at some point in the past. I'm not exactly sure when it was. Alright, so if we start filling these in, okay, that means U with A would be G, and I'm just going to call the mass of each just M because they're both the same mass. So it would be GM, I'm going to use big M as the mass of the Earth. Okay, oh, sorry, there's a negative here. Forgot the negative. Beep. Okay, much better. Meep. Alright, over, and they give us R, so we're going to leave that alone. The kinetic energy of A would be 1/2 M. Oh, I'm sorry. Why did I do that? Charlie just, never mind. Okay, over 2R. B, well, that's same M and same R, so it's still the same. And that's KB. Oh, that looks awfully the same here. In fact, I'm just gonna put some stuff together. I've got a GMM on everything here, so I'm gonna pull that out to the front. Okay. I also have an over R on everything, so I'm gonna pull that out to the front. Okay. That leaves inside, well, I've got by pulling the R out, that makes all these over 1. So in here I've got a -1 and a -1, so it's a -2 plus. Then I've got 2 of these. By pulling all this stuff out of the front, they were just 2 halves, so I've got a half and a half, so that's 1. Okay, well, that's -2 plus 1 is -1, so I should be getting negative G times the mass of Earth times the mass of each satellite divided by the radius of their orbit. So with my numbers, I'm going to be a little sloppy here. I'm having some trouble gripping my pen. I've been redoing my evaporative cooler for the summer, and it has involved a lot of scraping, like 6 hours of scraping. It's 5.97 times 10 to the 24th for Earth. And my hands are not holding on to things very well. I'm having some trouble holding this pen. Okay, R. 7.78 times 10 to the 6th. Wait, 10 to the 6th? Yeah, 10 to the 6th. Alright, let's see if putting that in the calculator gets us this answer. Indeed it does. I get negative 5.73 times 10 to the 9th, so I guess I'm off by a little tiny bit. That is probably having to do with something rounding here. I rounded to right there, but I probably should have put it all. In fact, I'm going to put it all and see if that makes a difference. It makes a slight difference, but not enough to round it. But it's close enough, so good. We did that right. Or maybe we should add in this well, it'd be so small. No, we're not going to do that. Okay. So next they want to know if the collision was completely inelastic, so the repetition remains in one piece as a tangled material. mass of 2m, what is the total mechanical energy immediately after the collision? Well, after the collision, because these were on the same orbit, the same radius, and they're both the same mass, well, actually the mass doesn't matter, they're both in the same orbit, they have the same magnitude of velocity, but since they're in opposite directions, then that means that they had opposite directions, and they're the same mass. So that means when they collided, the total velocity should be 0 when it's done. I don't even want to do that math. You guys should remember that from inelastic collision stuff. So that means their kinetic energy is 0. Basically, to find the total mechanical energy immediately after the collision, all we need to do is find the potential energy immediately after the collision. Okay, and again, potential energy is negative g, mass of the thing that's orbiting, mass of the thing in the middle, over the radius of the orbit. In this case, m is now 2m because they both collided. So when I plug everything in, I should get 2m, so what is that? 224. Mass of the Earth. Oh, I just did that. Yay, Google. Yay. Okay, over. Oh, I lost it. Where did it go? Nope, there we go. And now I lost my paper. Over 7.78 times 10 to the 6th. Okay, put that in a calculator. And I get negative 1.15 times 10 to the 10th. That is the answer. Good. Notice that the form that we had was almost the exact same form as, well, it was the exact same form as our last answer, except for this time it was m is actually 2 times m. So really we could have just taken our old answer and multiplied by 2. And that's not a problem. Okay, last question. Just after the collision, is the wreckage falling directly towards its center or orbiting around the Earth? Well, its kinetic energy was 0, which means it doesn't have a tangential velocity to move in a circle. So it would just go splat. So wreckage falling directly toward Earth's center.